We are very happy to be here. Hello, my name is Aleksandar Nikolov, and this is my colleague Florian Wisser. We are going to talk about digital inspections of bridges in Germany. At first, we'll take a look at our company and our team. Then we'll show a couple of examples from our projects from the bridge inspection team. Then we'll see existing workflows and new approaches and solutions. After that, we'll see the damage documentation on the construction site. And finally, we have a summary of some advantages and challenges. We are from ilp² engineers from Munich. Our company was founded in 2011 in Munich, and in these 14 years, we are growing constantly. So now we have branches at 3 locations in Bavaria, around 50 employees, and over 100 projects every year. Bridge inspections are a significant part of these projects. Damages on bridges and engineering structures, such as retaining walls and noise barriers, are a major concern. They require a continuous maintenance and testing in order to remain functional throughout their service life. That's why we cover different aspects in our portfolio, from inspections, structural testing, diagnostics, through bridge and structural engineering, maintenance planning, up until supervising on the construction site. What we see now is a part of our team. We are a very dynamic young team, and we recognize that structural inspections need to be made more digital in order to save a lot of time. Now we'll have a look at some of our projects. We'll start with a valley bridge of Schneitach. We did a main bridge inspection according to DIN 1076. This is a highway bridge with about 1,200 meters length, with a total area of around 44,000 square meters. It's a box section bridge with pre-stressed concrete with 13 and 15 fields, with effective span between 40 and 105 meters. In order to inspect the bridge superstructure, we needed to use a bridge inspection device. The next one is also a valley bridge. This is the valley bridge of Lemptower. We did also a main bridge inspection, and this highway bridge is around 600 meters long with a total area of 17,000 square meters. Also a box section bridge with 14 fields with effective span between 37 and 42 meters. And what you could see here on the right, this is one of our colleagues. The piers, they were so high that we need to use climbing technique in order to inspect them. The last one, it's a tunnel near Sontra. Here we did the first main tunnel inspection according to DIN 1076. It's a highway tunnel with 2 pipes with a total length of 3,400 meters with 28 parts, 2 operational buildings, 2 retaining walls, and 2 separating barriers. Now we'll have a look at existing workflows. And now let's see a video of an actual workflow. That's what we do on site. And that's what could happen. Well, yes, it's an actual workflow. Nowadays, we still have an example for lost papers in bridge inspections. So the 3 projects we saw, they were examples of big structures with a lot of documentation, a lot of sketches, which we need to take with us all the time on the site. We draw and record damage spots in these sketches and document everything with pictures. This could be quite tricky because we have to take so many things with us all the time, and sometimes we use platforms or are working in ropes. And at the end, we are done. We must digitalize all these sketches in order to have an input for our evaluation and for the final report. So the lack of digitalization leads us to a couple of problems. Incomplete and unstructured inventory data leads to insufficient building maintenance, which leads to reduced life expectancy. Building data maintained manually in analog form instead of centrally is inefficient and prone to errors. Costly post-digitalization and duplication of work for analog inspection costs time, and time is money. Paperwork is not legally secure and is comprehensible.
There are so many buildings and bridges around the world that need to be inspected. For example, alone in Germany, more than 21 million buildings, and the maintenance and life cycle extensions bring a big CO2 saving. So we have recognized this problem and continuously worked on the solution with our partner. Together with our partner, we have developed a digital product that solves our problems. Here you can see the web service of the app we use, and it allows us to have our digital building records in there, and they have secure data storage on servers within Germany. All the important standards are completely integrated, and the standards as inspection cycles for German bridges, for example, usually every 3 years, the building types, the component accordance, the component groups, the damage examples, the assessment criteria, the action planning and reporting in accordance with integrated guidelines. And the inspections built on previous inspections, this enables the condition of the building to be tracked over time. Roles and rights can be customized, so you can approve external subcontractors for individual structures or inspections, or for example, you can grant reading rights for decision makers. The open interfaces enable networked working and planning. On site, we only need a tablet, so no paper anymore, or a smartphone, and we can document our inspections with the app. So if we have a damage, we just point a pin at a place in the drawing, in the app, and then we can put in all our informations we want and take pictures. So the app allows us an on-site condition assessment on the tablet or smartphone, and it's available for Android and iOS. It's really intuitive and straightforward to use, and it's fully functional offline. So you just synchronize it afterwards at the office. Multiple localization of damage and hand drawings can be made in the plan, and complete damage assessment in accordance with integrated guidelines can be performed directly on site. For example, according to the criteria of stability, of traffic safety and durability. And the inspections can also be carried out with several inspectors working on one building. Afterwards, in the office, you get the reports at the touch of a button, so there's no more duplication of work between the field service and the office needed. Also no time-consuming post-digitalization or manual reports. But if some changes are required, a post-processing can be done in the web service. The export of the report is to MS Word, which makes it easy to insert additions. The reports and checks build on each other, so they are really transparent and comprehensible. And you get directive-compliant reports in accordance with German standards, such as 1076. And the customized reports templates can be modified at any time. In the end, I want to talk about the advantages and challenges we have. The big advantage is the time saving up to 50%, since there's not really much work in the office needed afterwards anymore. It's really easy to learn, and it has an open interface via IFS. It has many application options, and you can use it offline or use multi-client options. Still challenging is that German standards miss new development with ZIP 2.0 database, so actually an interface for export to ZIP is needed. And not all types of structures and damage examples are already included. So thank you very much, and feel free to get in touch with us. Thank you.